In this video, we're talking about Maclaurin series, and if you didn't watch the first video about sine, I suggest you go back and watch that first. I'm going to go a little quicker in this one, and we're going to look at cosine this time. So let's start with y equals cosine of x, and the idea of a Maclaurin series is you can approximate a function with a polynomial by looking at the value of the function and its derivatives at a single point. So we're going to look at 0 as our x value. And so what we start with when you start by making a Maclaurin series is you just start by taking derivatives of the function. So if f of x is cosine of x, then f prime would be negative sine of x, f double prime negative cosine of x, f triple prime would then be positive sine of x. The fourth derivative would be cosine of x, and the fifth derivative, it keeps cycling through sines and cosines and through positives and negatives. And so we use the value of that function at 0. And so if we plug in 0 to the function, we get 1. That's that initial point. If we plug in 0 to the derivative, we get 0, negative 1 for the second derivative, 0 for the third derivative, 1 for the fourth derivative, 0 for the fifth derivative. And so setting up our Maclaurin series, and you can actually watch as our approximations improve here. We're going to start with the very bad approximation, which is just y equals 1. This matches the function perfectly at x equals 0. So we take y equals 1, and then we add the next value, the derivative, times x. It's 0. I didn't really need to type it, but I can type it there. And it's x to the first power. Again, that's a little redundant. It's divided by 1, also redundant. The second derivative has a value of negative 1. It's the second derivative, so I do x squared, and I divide it by 2 factorial. The factorial is redundant there because 2 factorial is just 2. And you can see how it went from being a straight line that is a very bad approximation to now it's a parabola, and that's a little bit better of an approximation. The next one would be 0x to the third divided by 3 factorial. That didn't do anything because it's a 0. Then we have plus 1x to the fourth divided by 4 factorial. And you can see that that fourth degree polynomial really hugs cosine very closely. I'm noticing that all of the even powers are the ones that exist here. And so I can go minus x to the sixth over 6 factorial. You can see it's a better approximation. Plus x raised to the 8th over, over 8 factorial, and you can see it's better. And we can play this game as long as we want. The idea is that we can achieve any degree of approximation that we want as long as our original function is sufficiently nice. So that's that for this video. In a couple more videos I'll make soon with other examples of Maclaurin series.